Uh, Hi Rishi, thanks for joining us today. We are doing this interview as part of a big data curriculum. We are asked to talk to an domain expert about to get an insight in the industry.
Okay.
Uh, Thanks for your time. My name is Anbu. We have Mahesh, Karthik, Supraja, and Sai Krishna along with us. Uh, yeah, Mahesh will start with the question.
Yeah.
So first, let me introduce myself before you
Yeah,
shoot up questions to me. So
okay.
hi guys, this is Rishi. I'm currently working as a data science and analyst. So my part is mostly into R&D, and I'm working at PDF Solutions. And I am mostly dealing with your topic, big data, in my day-to-day life. So yeah,
Right.
let's get into the conversation. Yeah.
Thank you.
Yep.
Okay. Hi, Rishi. I'll just shoot out the first question. It would be good, like in your day-to-day practice in your job, right? Like, what tools like do you use for like modeling the big data? How do you structureize the data? If you could talk about how do you pre-process it?
Yeah. So let's get into the topic which you want me to talk about is the big data. So
Mm-hmm.
in my daily life, I do get lots of data coming from multiple clients, and mostly it's in the unstructured format. So once we get that data, we usually use the Parquet files to transfer the data from the client database to our database. So once we get the data in our database, we store it in Cassandra. So Cassandra is the big data tool or the technology which we are using to store the unstructured form of data. Because so suppose if I'm getting like around 200 gigs of data, it doesn't make sense to keep my resource and utilize those 200 gigs to just store the data. So what happens if I use Cassandra is I can compress the file size to a smaller size. So I can compress it from a 200 gig to suppose 100 gig. Even that is a good compression, but I can do a compression of up to 80% to optimize my file size, and after that go on the further process of chunking the data. So in Cassandra, basically, it's an unstructured database, and you can have clusters that are the nodes which you can create. And based on the use case, I can create multiple Cassandra nodes. So up till now, I have for the big data which I am handling right now, I have used a maximum of 4 Cassandra nodes. That is the 4 clusters which I'm using currently. And the tools, yeah, that is the tool which I'm using to get the big data, handle it basically.
Mm. Okay, yeah, I got it. Thank you. And like one more thing that I wanted to ask, like, how do you choose like what platform you want to go to? Like, for example, you have multiple warehouses in the market right now, right? So,
Right.
like, how do you plan out? Like, I want to choose a specific warehouse.
So multiple things are taken into consideration. The first and the most important thing is the requirement of the client. So if the clients are familiar and they are like they converge on the same point that they are okay to share the data on a Cassandra database or any database which we are using. So it basically depends on the client requirements more than our requirements. So we can handle both structured as well as unstructured data. It depends on the client requirements. If we are getting unstructured data from the client, we use Cassandra. If we are getting structured data, we use Oracle to store because it's a relational database, easy to pull out the data from the database and do the analysis in day-to-day life. So depends on the clients basically what type of data which they are providing and how basically it's how compatible are they sharing the data in that structured format with us. And also with the upcoming big data, the volume of the data is too large. So we prefer using the cloud technologies. We choose Cassandra as our database, and we spin up the servers based on the data. We use a big data API. which we use to retrieve the data from the database and push it back to our S3 buckets on the AWS cloud side. So that's how we handle the big data. Yeah.
Yeah, got it. Thank you.
So Rishi, this is Karthik.
Hi,
So
Karthik.
whenever you're dealing with the real-time processing data,
Mhm.
so such as images or the videos or and such kind, how would you deal with the latencies or the delays?
That's a good question. So, to answer your question, the projects which I'm currently working on, in that, like, I'm working in a semiconductor industry, so most of the data which I'm getting is out of the equipments or the tools. So, on the tools, we have the sensors. So, to answer your question about latency, we are collecting the data at a frequency of 1 hertz. So, for on each sensor. So suppose we have a temperature sensor, we have a pressure sensor, we have multiple sensors on the semiconductor tool. So we are using the frequency of 1 hertz to collect all the data. So that's how we are managing the latency. And I think so it's pretty good if I'm collecting the data at a frequency of 1 hertz to do the real-time analysis. So currently I'm doing a real-time analysis for the tool prediction, the wear out of the tool. So suppose there is some issue or the problem in the tool, I use the sensors to collect the data, and based on the data which I'm getting, I can try to understand whether that tool is going to wear in certain time, or will it, or is it performing good, or is it going to wear out after some time, because I have the time series with me, and I have the continuous data which I'm gathering from the sensors. So that's how I manage.
Okay.
So I don't see any latency because on the projects which I'm dealing currently, but definitely there is going to be, if you are considering images, definitely there is going to be some latency which you can see. So yeah.
Mm. Then I would also ask a question about the latest developments of big data in your industry.
Mm, okay. So the latest thing which the industry is moving towards is the edge technology. Uh, Cloud is also there. Cloud computing is obviously there to optimize the resources and to use the resources more efficiently. So with the big data, the upcoming trends are into doing the data analysis, and like in automated data analysis, basically. So you have these real-time dashboards, and you have the data, streaming data continuously coming from these sensors, and you can see the dashboards. So basically, why we build a dashboard is to see the yield of the product. So we can, so our main goal is to optimize the yield, because if there is a higher yield drop, it means that we are going to face loss. So in order to save money, in order to save, because if there is a chip in the market, and that is, you know, that that particular chip is going to die after some period of time, it doesn't make sense to just do the work on it, get the etching done, get all the process done, and get the chip ready in the market, because that chip, suppose that chip is in your phone and your phone stops working, so it's a bad chip, right?
Yeah.
So yeah, it's good to do the real-time analysis of this. So the current trend is moving towards this. And one more thing, it's a large amount of data which we get in our day-to-day life. So it's difficult to handle it as well, because sometimes it's sensors, right? If the sensor is not working fine, it is just going to give me all shitty value, like not shit. It will basically give me all random values that I'll consider as noise, basically. So it's of no use for me. So
Yeah.
yeah, understanding the data is more important in that scenario.
Yeah.
Yep.
Rishi, you spoke about edge devices, and that is the next big thing happen. One of the next big things happening in the field. In
Not
general,
edge devices. I'm talking about the edge cloud computing, the edge technologies which are coming up. Yeah.
okay, edge cloud, not the
Edge
devices. Okay,
technologies. These are basically the edge technologies which are coming up. Yep.
okay. The next thing I wanted to ask, get a clarity on is you said about cloud, how it is beneficial for you using a cloud service to process your data.
Mm-hmm.
And obviously, Amazon is one of the pioneers in providing. Have you considered Amazon's DynamoDB in place of Cassandra?
So
or
to answer your question, it's a no. I have not considered Amazon's DynamoDB because of the cost issues. So mostly what we prefer doing is we get these like we get the sensor data, the tool data from the customers. We store it in the Cassandra database. Then to do the further pre-processing of the data, we use our own models to do the univariate screening, to do the bivariate screening, to screen out the useless features. So for that, we are using the AWS instances.
okay,
So yeah, we will spin up the servers to run our models because it's suppose if I'm getting the data from multiple devices or the tools. So in a fab, we have around 50 to 300 tools. So getting the data from them continuously, real-time data, to process it continuously, it is going to take huge computational power. So for that reason, we are using the cloud services to spin up my instance whenever it's required, to get the screening done, to get the less like a fewer set of parameters for me to do the modeling part of it.
okay. Uh, can you give us a brief about the pipeline that you use in your project? Yeah,
Yeah,
please.
sure. So as I was talking before, so suppose if I'm having 5 tools, I'm collecting the tools, I'm storing it in the Cassandra database, which is the unstructured format. I have a thin client architecture for that. So what happens behind the scenes is my data goes and it stores into the Cassandra database. I have 4 nodes for that. On top of that, now let's talk about how the pre-processing is happening inside my pipeline. So what happens is I'll collect all the data, I'll push it into my univariate screening. I've got one response. I'll do the univariate screening. I'll get out the important features out of that. I'll pass it to the bivariate screening. In the bivariate screening, I'll group like the families which are correlated to each other. I'll pick the most important feature which is affecting it. So I've screened down to a few set of parameters. After that, I built a multivariate model. So building a multivariate model using XGBoost because the response time of XGBoost is faster and I can actually handle the computational power of my CPU, basically utilization of my CPU using XGBoost. So using that, I can use my resources more efficiently to get the result as quick as possible, because handling large amount of data doesn't mean that it's always required that I need all the cloud technologies. It can be handled in a smart way to get it to a smaller size and then use it for prediction, for predictive maintenance, for predicting your yield. So like for multiple predictive operations you can use it.
Uh,
So that was the basic pipeline which I was talking about. So it's like Cassandra. Cassandra is like a unstructured format. It stores the data in the columnar format. So after that, I have an Oracle database. In that I have all the relational data. So that's how I can fetch the data in my tool. So the tool which I'm using currently, it's the Accenture tool. It can handle big data as well. So
okay,
that's how I'm using it. And I'm using a big data API to collect that data and push it into my Cassandra database.
okay. Uh, I have one more question.
Mhm.
How do you handle the security and privacy concerns that
Okay,
comes with
so that's
such
a good
huge
question.
data?
That's a good question. So first of all, when we get the data from the client, it's log files. Many clients prefer giving us binaries, ones and zeros. So we run a Python script to convert that data and get it into some sensible, readable format like CSV files, or to be honest, we convert it into Parquet files. Parquet files will keep your data compressed, so it will not utilize much space. And after that, it's on the cloud, as I said. So on the cloud, if you store the data, you can give the users who can access the data. So you have the authentication. So we authenticate the users. Suppose this guy is a process engineer, he should just have the data related to the process. He should not have data related to the fab. So that's how we do the security for the data. And how we think the data, it's basically in the form of binary formats and like all different formats, XML format, log files. So we have to clean up the data, and sometimes it's in XML format as well. So we have to clean up the data and then store it into our database.
what has been the most challenging project that you worked on, and what has been the what you would say the most breakthrough project that you worked on so far?
Uh, Challenging project. Every project is basically challenging. It's just how you try to work on that. So if I give you 200 gigs of data, but you don't know how to handle that file, how to open that file. So that is basically going to be challenging for you. Yes, so I'll not go in detail about what project I found challenging, but I would say that I had data from multiple steps, you can say. So I had data from multiple technologies or the tools, you can say. So I get data from so in a fab, you have multiple tools. You have a etcher, you have a litho tool, you have a time series tool, you have FDC data, that is a facility data. You have the wafer data, you have the wafer sort data. So there are multiple data types which you get. So the first important thing is to understand the hierarchy of the data, and the second part of it is to tackle the problem which you are facing. So to handle the big data, you should first understand the data. So that is the key challenge in doing the data analysis and the modeling part of it. And how I tackled this, how I tackled that problem was to understand the hierarchy. Basically, I tried to chunk up the data into small parts, and I tried to analyze and visualize it before I just push all the data into a model and let the model fail. So yeah.
Hey, I just had a question on you're explaining about the ETL pipeline, right?
Mm-hmm.
So so while developing like what tool or what technology do you use to orchestrate all this? Like you told, like you pick the data from Cassandra, right?
Right.
So what tool do you use to build all the ETL pipelines?
So to build the ETL pipeline, so I myself, I have not built a ETL pipeline. We have our own ETL pipeline, which I use to do that is basically used to load the data and do the transformation for me.
Mhm.
What I focus is mostly on how we are getting the data and how it should be handled. So that part is on me. I don't do the pipeline part of it. Like we have our own tool which handles the ETL pipeline for me.
Okay.
Yeah. Okay, I see. Yeah.
Uh,
Go.
any other questions? Uh,
Have you ever considered anything other than Cassandra from
Um,
DBT?
that's a good question. I've worked with Spark, but to be honest, I didn't like it.
Cassandra?
So, Spark,
Spark, okay.
yeah,
Mm.
I didn't like it. But one good thing about is it's faster. You can chunk it up into smaller parts, and you can parallelize the entire process with Spark. But no, like I have preferred using Cassandra.
Okay.
Yeah. Because it again depends on the use case which you are using. So for our use case, it suited the best amongst all in terms of time and everything. So yeah.
You said you will be getting the unstructured data from the sensors of the machines, right?
Hmm.
So how would you be making it structured or something meaningful?
So yeah, in the Cassandra database, I store the metadata, and I'm linking the metadata to my Oracle database in which I'm storing the structured format of the data, and then I
Okay.
use my retrieval process to just retrieve the data from the Oracle database. And my entire outline of metadata lies in Cassandra.
Oh,
So that's why my retrieval is too faster, because whenever I need to retrieve something, it goes through the Cassandra, and then Cassandra triggers the Oracle database to fetch out that particular data set. So yeah, it's faster. It's a hierarchy of both structured and unstructured data.
okay.
Yeah.
Um, Hey Rishi, this is Sai Krishna.
Mm-hmm.
I hope I'm audible to you.
Yes.
Yes, okay. So, uh, like in the initial days of my work experience, I got to work on somewhat of big data where we have used Spark and Scala and also Hive and Hadoop.
Okay,
So Hive is also a kind of database like similar to SQL that uses for the big.
right. Is he audible to you guys?
No,
Okay.
Sai, you're
So,
not audible.
Sai Krishna, I think you
Used
can ask to the
Cassandra.
chat.
So what do you feel that is advantages in Cassandra compared to other? And you have also mentioned Spark. So what do you feel that's advantage in that?
That's a challenging question to ask. So basically, what I why I prefer Cassandra is because I can create multiple clusters and nodes out of it and then merge it to a single file, which I can do very easily, chunking up the files and then just making it. So it's similar to MapReduce if you're talking about HDFS, but this is a more kind of a distributed file system rather than the other formats like the MapReduce. It has to be like in the MapReduce there has to be some mapping, and then you are extracting and making a single file out of that. So yeah. So to be honest, I've not used HDFS file system and your Hive and Hadoop databases in my day-to-day life currently.
Okay.
Side to answer your question, yeah.
Okay. I have one more doubt. You spoke about how you break it or containerize it. How exactly is containerizing helping you or making it easy to go ahead with the analysis part? And what is your favorite tool, or do you have any preference to which tool do you prefer for this containerization?
So containerization and orchestration is basically Docker, and we are using our own DexNet network, which we basically use to pull out the data and push it to our databases. So in the clients, so basically there are two ways to handle this problem. It's firstly on the client end, they can have their own servers, or we can set up a cloud platform for them. So if we use the cloud platform, they can share their data directly with us. But if it's a server, then we have to push some protocols to retrieve the data from their server to our server. So it's more flexible if we are using the cloud services. We get the data there. Once we get the data on our cloud, we use Cassandra to store the data, and after that, we are using how we are doing the containerization of that is we are chunking the data into multiple clusters. So that's what I'm talking about is the Cassandra nodes. So suppose if I'm having a huge data set or a huge big data basically, so I can increase my number of Cassandra nodes. So that's scalable actually. So it's suppose for one of the project it was a huge data. So what we did was we used actually four Cassandra nodes, and we used four app servers to handle it more efficiently. So it's like a multi-tenant application. So multiple people will be fetching and doing multiple parts on the data at the same time. So there should not be any latency, as well as they should be able to efficiently retrieve the data out of the database. So that's why we use multiple clusters, and it's all replicated, so there will not be much issues in handling the data basically and doing the analysis is the second part of it, but first it's about storing the data and getting it in a good shape and format in a good alignment basically.
Uh, Thanks for answering, Rishi.
Yeah.
Guys, any other questions?
No, that's it.
Uh, Thank you for your time, Rishi. It was an
Okay,
insight
thank you guys.
talking to you.
Mhm.
Hope we do uh, have one more session where we speak further about the insights. Thank you so much for your time once again.
Okay, thank you. Bye bye.
Thank you. Bye bye.
Thank you so much.